So we're into solving equations, and I know you've done solving equations before, but I really want you to understand what you're doing. It's not just steps that you follow, it's understanding what's going on. So if I had x plus 5 equals 8, my goal all the time is to get this x by itself. Because when I say that x equals something, what I'm saying is that x is worth a certain weight. If I had a scale, these would balance out. An equal sign means balance. And so if I have a number over here, like 3, then I know that x has the same value as the 3 on the other side. So when I have an equation, here's my balance. I'm saying these two sides balance out. And so I want to keep it balanced. And in order to do that, what I do to one side of the equal sign, I have to do the other so that it stays balanced. Now on this one, I have an extra plus 5 here, right? I have the x, which I'm trying to get by itself. I have a plus 5. And in order to get rid of something, you have to do what we call an inverse operation. Every operation, oh, I spelled that wrong. Oof. Every operation, adding, subtracting, multiplying, dividing, it's basically the way we say a verb in math. Every operation has an opposite to it, an inverse to it. For adding, if I'm adding, the way I undo, inverse means undo, the way I undo adding is I subtract. So because I'm adding 5 here, to get rid of it, I would subtract 5, but then I want to keep it balanced, so I have to do it on the other side of this scale, meaning the other side of the equal sign. And when I do that, these guys are gone now, and I just have the x that I had on the left, and then on the right, I had 8, but I took away 5, so now I have 3, so I know that x equals 3. Inverse for subtraction is adding. So if I have x minus 5 equals negative 13, once again, I've got this balance here. This side and this side balance out. And so if I have a minus 5, the inverse of that would be adding 5. And look at that, we have our 0 pairs here, right? Adding 5 and negative 5, they 0 pair each other out. They're gone. And so now I just have x equals, and then negative 13 plus 5 is negative 8. Now you'll notice when I write my equations and I solve, I have this line right here where I show that I add or subtract. You must do this. I need to see this from you. I want to know what you're doing to solve your problem. Sometimes when you have a problem, you need to simplify it first before you go ahead and solve it. So if I had a problem like this, I've got too much going on here. I would rather not have all that. So I'm going to rewrite it. And if I'm in the negative world to start with, then this is putting me in the opposite world. So I'm in the negative, I flip over to the positive. So this is really a plus 4, right? We have 2 negatives. That's really a plus 4. And now I can see that I have my balance scale. I want to get n by itself. So I need to do the inverse of adding 4. I need to subtract 4 on both sides to keep it balanced. We've got 0 pairs now. And so n equals negative 12. A lot of times when you get a word problem, I'm not going to go through one here, we did in class, but when you get a word problem, your first job is to set up an equation. That's the cool thing about math. We take things from words and from complex problems and we simplify them by making them an equation that we can solve. Then we solve the equation, then we go back to our problem. So even though you might look at a word problem and think, oh, this is really complicated to put it as an equation, it's actually our way of simplifying things. And I know it doesn't always seem like simplifying at first, but we have to start at the simpler stuff before we get to the really complicated stuff, and it really starts getting confusing, because if we know how to simplify it into an equation, it's not going to be as confusing in the future.